Hello everyone, my name is Dewi from Department of Information Technology, Satya Wacana Christian University, Indonesia. Today, I will present my research title YOLOv7 for face mask identification based on deep learning. This is my outline of my presentation today: introduction, related work, methodology, experiment and result, conclusion. In 2019, the coronavirus, known as the COVID-19, caused the widespread devastation across the human population, regardless of the age, gender, and the geographic location. The COVID-19 pandemic has presented a significant obstacle to the entire planet. The techniques, including the artificial intelligence, can assist humans in their fight against the virus in a variety of different ways. As the primary line of the defense against the COVID-19, the researcher recommend that we must implement a unified strategy that consists of wearing masks in a public as a primary form of protection. To begin with, a novel deep learning detection model has been presented, and one that can automatically recognize and locate facial medical marks within images. And the second, the evaluation of the advantages and the disadvantages of using You Only Look Once YOLO version 7 to identify medical face masks were both included in this study. In the following section, we apply our suggested technique to the MERS face marks dataset FMD and the medical marks dataset MMD. The related works as follows. The identifying things is easy for people, but very challenging for computers to distinguish between two things that are almost indistinguishable from each other in terms of appearance and purpose. When people are required to wear face masks, mass attention is usually focused on their makeup as well as the identifying their identity. This is the case in most situations where a face mask is required. A comparison of masked and non-masked face recognition dataset is provided in Researcher 10 along with the presentation of the Principal Component Analysis PCA. And they have discovered statistical procedure as part of their research that have the potential to be utilized in technique for maskless face identification as well as the masked face recognition. The YOLOv7 architecture is a combination of YOLOv4, scale YOLOv4, and the YOLO-R. In order to develop a new and improved version of the YOLOv7, the additional experiments were carried out using these models as a foundation. In our works, we implement the original version of the YOLOv7 and training it with the FMD and the MMD dataset. The methodology in our experiments in this paper were conducted using two publicly available medical face mark datasets. First, the face mark dataset FMD. In the reference 24 and 25 is the publicly available mask face dataset. This dataset contains of 853 images that make up the FMD dataset and all in the Pascal VOC format. Next, the medical marks dataset, MMD, is available on a Kaggle. The MMD dataset consists of 682 images, each of which contains over 3,000 medically marked faces. The MMD dataset consists of three classes with class name bad, good, and known. And for the FMD dataset contains three classes with the names marks were incorrect, with marks, and without marks. That is why our experiment explains that the three classes as follows. Bad is the similar with the marks were incorrect, and good it is similar with the with marks, and non it is similar with without marks. Our combination dataset, the MMD and FMD dataset, which contain three classes, namely bad, good, and non. The bad class consists of almost 500 instances. The good class has more than 4,000 instances, and the non class has approximately 500 instances. This is the research workflow for our experiments. From the input is the combination of FMD and MMD dataset. And then we will training with the YOLOv7. Start from the extended efficient layer aggregation backbone, and then the wrap ResNet neck, and then we will have the output. And this output, we will analyze the result. The face mark dataset was trained using a system that has an NVIDIA GTX 3060 Super GPU accelerator and an AMD Ryzen 7 3700X CPU and 8 cores, as well as the 32 gigabytes of the DDR4. And our dataset is divided into two parts, for 70% for training and 30% for testing. As we can see in figure 2, this is the train batch 0 with the FMD and MMD dataset. In figure 3, we can see this is the test batch 0 labels with the FMD and MMD dataset. In the figure 4, we can see the precision and recall curve during the training process. And the highest one is the good class with 98.6%, and with the all classes is 63.2%. For the experiment and result, we can see in the table 1, this is the training performance of YOLOv7. We divided into the class. This is the all class, bad, good, and non. The total images is 456. And this is also have the information for labels for each class, and the precision and recall, and the MAP value. For all class, the images is 456, and then the level is 2154 with the precision 60.9% and recall 93.1%, and the MAP is 63.2%. For the highest score is achieved by the good class with the precision 93.9%, and the recall is 97.8%, and the MAP was 98.6%. That one is for the training, and for the testing, the performance is the same. We divided by the three classes, bad, good, and non, and with the all class. The highest score is for the good class with the 456 images, and the labels is 1,733 labels with the precision 95%, the recall 97.6%, and the MAP 98.5%. As we can see in the figure 5, this is the recognition result of the FMD and MMD dataset with YOLO version 7. So the conclusion is as follows. The purpose of this research is to present a clear and concise summary of the CNN-based face mark recognition methods with the YOLOv7. Based on our experiment result, YOLOv7 achieved the highest average MAP of 64.6% for all classes during the training and testing stage. And for the class good, this one is achieved the highest MAP for YOLOv7 with 98.5%. We focus on the class good. That means our algorithm can detect the people wearing masks precisely. Moreover, in the future, we will enlarge the dataset, reduce the imbalanced data, and add not ideal image or noise. We will explore the YOLOv7 pose estimation in the future studies. Thank you for listening. See you.